And again, this, even though I did this a lot of time, I still use this as a way to practice. So practice speaking, right? So next is Kubernetes. Hooray, hooray. What is Kubernetes? Oh, I don't know if it works for the other slides though. So basically, it's a cluster and container management tool. And one word is, not one word, two words. It's an orchestration tool. Okay? It was open source 4 years ago. It was built by Google 12 years ago. So we're pretty safe that it works. Okay? So what do we compare this for? So let's say we have a AWS, and AWS has CloudFormation as its own orchestration tool. But the problem with that is CloudFormation can only deal with AWS. And that's how Kubernetes is different, because it can be an orchestration for many different systems. So try to make this easy to understand. So here's a Kubernetes cluster, and you would see, I think I have a laser. Oh, this is the master. Okay, focus on this for now. So a master has these four components, and a master has the etc. D. I don't know what it means, but basically just stores all cluster data. And it definitely needs to have an API server because it needs API endpoint so they can communicate with each other. You also have the controller manager so it could regulate the state of the cluster, and scheduler servers to assign workloads to nodes. Yeah, it didn't work. Sucks. Okay. So what is a node? So let's go back first again. And this is a node. This is a node. This is a node. This is the master node. And we now ask, what is a node? So a node will consist of basically a Docker. It uses to run your container, or another alternative. We keep hearing Docker, right? They pronounce this rocket, and it looks like rocket science, okay? So a node would have this kubelet. It's, again, the one that exposes the API to communicate, and also has a proxy to maintain rules and performs network forwards. And if you're curious why there's this Black Mage Final Fantasy here, it's because a lot of this is magic. I mean, it's nice to know what it looks like, but once you're doing it in DevOps or as a software developer, you don't really see those stuff. And then next, we talk about pods. So if this is the node, these are pods. Okay? So a pod is a basic unit in Kubernetes. It represents a unit in deployment. It is mortal and have a life cycle. It means that if you have a visualization, it means that you would see a node and you would see a lot of, like, let's say, color green, and that would define each node. And it can also die, and it could also provision another pod to do some workloads or processes. And things that you can do is you can define a service. A service can group together collection of pods, even though they're in the different cluster. So as you can see, this one and this one, it's a different service, service A, service B. Okay. Next thing that we have to know that you can also label them. Let's say I label this as B, app B, and this is app A, and it could be in different clusters. And again, we're grouping pods. Deployment, it just provides a syntax to create and update pods. You basically configure to put how fast do you want the pods to be up, and how many pods do you want to have in one node. Next would be, this one is too much, let's skip that. Summary, a pod always runs on a node. So basically each node is a server and server is just a computer. So in short, your computer or your node has many pods. Basically, you would try to have divide the processes that a computer can do. A node is a worker machine in Kubernetes. It can be virtual, physical machine, depending on the cluster. Each node is managed by the master. The master is the one communicating, saying this is what you need to do. A node can have multiple pods, as I've explained earlier, and you can automatically schedule pods, provision, just configure it. That's the last line. Okay. And every Kubernetes node, basically the node that I'm saying, has a kubelet. Again, it's the one that's responsible for communicating. Again, that's the API. And also, a container runtime like Docker or Rocket would be the one responsible for pulling the container image. Again, container is different from, container is being used loosely all the time, so we might have a different time for that. Next. I got lucky and was gone to a advanced Google workshop. They say, oh, it requires you to have introduction level, but I signed up anyway. It didn't look, but that's totally fine because I know they will teach you like, they would guide you line by line, like hands-on. So I went ahead. So basically they taught us how to use Spinnaker. Basically it's continuous delivery. If you have Kubernetes here, you basically have Spinnaker to enable more orchestration for your Kubernetes clusters. Because before you have Kubernetes and it's hard to create different clusters, maintain them. And if you have Spinnaker, you can now orchestrate those things and manage your Kubernetes clusters. So also they taught us to use the Google Container Registry to make small changes. Yep. And then also Canary, this is also being used in deployments. You would hear that a lot. Load balancing, advanced routing, Prometheus, Grafana, tracing with Jaeger, Service Graph, and Google Stack Driver. So I won't bore you with all the details, but I'll just show you a quick thing how they look like. So again, this is cluster, the Spinnaker, and now they're all being controlled by Spinnaker. And container registry, and you would use the scaffold to make small changes in your dev environment. Next, this one is staging to Canary, so you're deploying it simultaneously. And then next is doing this Istio ingress. It adds more like monitoring and visualization stuff. And then this, again, more monitoring. And I'll show you how it looks like. So this is very cool because with a Spinnaker, you would see those green. Those are the pods. So you would see how many pods are running, right? And this one, you would see your process and what's happening as well. And this one would be the Jaeger. It also shows you your different backend productions. And this one would show you the operations and the number of traces. Istio, monitoring, troubleshooting, don't have a visualization for that. Prometheus, I don't like the UI, and then I don't even like this graph. Grafana, it's gonna give you real-time information. Let's say you do load balancing, you put load balancing to one server, two servers, you get real-time updates, and it's really nice to see that visualization. So like this is one backend server, and the other one is another backend server. Service graph, wow, it's like, this is like, I don't know if it's data science stuff. So once you executed everything and you integrate service graph, you would see all the things that, the runtime, and they move. It doesn't move here because I just screenshotted it. And even this one, it moves. It shows you all the components. Google Stack Driver, it's a known monitoring tool when you're using Google Cloud. And I think that's everything. So thank you. Don't ask hard questions.